Welcome back to the project, everyone. Today, we're going to mess around with the CNC a bit more. Again, this is a Genmitsu 2030, and the last video, which you haven't watched, you should go watch it, we modified this a bit and fixed some things with it and then did some test cuts with it, but this project is going to be a fun one. We've got some things to fix, we've got some upgrades to put on it, and I'm actually going to get into the programming and we're going to try cutting some stuff. I'm hoping by the end of this video that we can cut some aluminum. That's my hope, but we'll get there. When I got the CNC, it didn't come with like any bits at all. Basically, it just came with some like little engraving bits, which were okay, and you know, you saw me use those last time. So since then, I've done a ton of research and I've gotten a bunch of different stuff. So we do need to unpack that stuff, which I already did. So we'll put in the clip here. In getting the CNC router, they came with these bits, which are 10 like 30-degree engraving bits. So I don't have any end mills. I don't have anything other than these. So I did go on a little bit of a spending spree. And we got some fun things. So we'll deal with that in a minute. But right now I just kind of want to go through these. I got this bit storage tray, which maybe I'll actually use. The problem is most of the stuff from Genmitsu is like in nice little cases already. So do I really want to pull them out of these cases that tell me what is inside a bit? Or yeah, so we'll deal with that. But I at least wanted to get these kind of opened and all out. To quickly go through it all, we got the storage tray. We got a bunch of bits, and then we got collets. So I did have to learn about collets a little bit. Most of the stuff come with an ER11 collet, and I just got all of these so I could really fit any drill bits or anything that I want. But the main ones that we'll use is this 1/8 inch collet and this 1/4 inch collet. It comes with an 1/8 inch collet, but you know, now I have all of these collets. So as far as the bits, Genmitsu did have a sale going on. So I mean, like, I got a bunch of cheap bits, just a bunch of cheap bits. And so I can practice with these, play around with them, and then see how like well they do for the money. I know they're just cheap Chinese, but at the same time, I also bought 2 Amana, I think that's how you say it, bits. And the 2 bits that I got are a 1/4 inch engraving with titanium nitride 30-degree, and then a single flute flat end mill, or it's like, yeah, an end mill. And they're both were quite expensive, but I mean, like, yeah, that looks so good, and the quality is just top notch, made in the USA. If it wasn't so dang expensive and I didn't know, if I knew exactly what I wanted and I had a bunch of experience, then I might have just gone straight to only Amana tool bits. But because I have a lot of learning to do, and I think a lot of the stuff I want to do is just non-critical, then I can have all of these for cheap and play around with them, and then when they break, get actually good tool bits. So yeah, and that's where these cases, like, these are awesome. I want to just keep them in the cases, so I don't even know how much of this I'll use. But anyways, let's just get into it. I want to break these all apart, get them all spread out, so then I can actually start using them. So let's do that. One of the things that we really need to do to this is actually my CNC broke. And let me show you how exactly it broke. Okay, so on my CNC, if we just turn it around, I mounted the control board here on the back, and I haven't peeled it up or anything. And that's great, I really like this setup, but the eagle-eyed viewers among you might notice we have power on here. We have 48 volts, 28 volts, the whole thing's powered up. And look at my power switch. It's off. So my power switch doesn't do anything. And the other thing that's also dangerous with that is my emergency stop is also broken. I did reach out to Genmitsu, or to SaneSmart, and they sent me a new board. If you want, I did actually look into this and figure out what was wrong. And essentially they just have a MOSFET in there that is when it's high, when it's the same as the voltage input, it doesn't let anything go through it. And then this switch will pull it low and allow it to go through. And then the E-stop will pull it high and thus shutting it off. So left alone, it's off. E-stop forces it off, but then this can pull it low and go on. So that MOSFET on there just kind of died. And there's no hole in it or anything, but maybe once we get it off, I'll show you. But we do need to swap this out because, you know, if things go awry, I want to be able to stop it. And right now, I literally have to unplug it to turn it off, which not that safe. So this is the first thing on the agenda, and let's get it swapped out. I guess first we'll unplug it, and you can see how long it lasts. There we go. Whole new board. I will say, I love having my power supply mounted up here like this, but I did realize that the USB comes on this side, and that's why you can't mount it up like this too much. But I did have these little right angle USB connectors, and then I just use a USB extension from this side. But I will link these in the description, and you can figure out which ones you want to use and what ones will work best for your scenario. Because yeah, right here, this is really tight in here, but should be nice and tidy. And one other thing I will say, while I'm trying to struggle to get this on, is that the other control board that I had, it worked for like, you know, a few hours kind of a thing, and then I just had it on my desk, and I had it turned off so that way this fan wasn't making noise, and then it just randomly turned on when I was kind of messing with some thing. Well, I wasn't even touching it, and then it just turned on, and that definitely that made me a little concerned, but we got it figured out. Anyway, so yeah, I was just sitting there on my desk, and then it just randomly turned on, and then I was like, what the heck? And so I troubleshot it and figured out what the issue was. But ultimately, them giving me a new board is the best fix. Alright, new board is in. Let's see. Okay, nothing on. And then when we hit, whoop, there we go. And it turns on, and if we hit this, shuts off. Okay, I will call that good. Okay, so figured we might as well take this apart and show you how their circuit works for the input, or for the power switch, since it is kind of fun, and I figured out how it works. Just gotta take off these screws. Right up here, so that's for the spindle, these two, and then this is for, so these two are for the voltage input, and the other two are for the spindle. And our culprit here is actually this guy right here. And so we have a little replaceable fuse here, which is great. Honestly, love to see that. And we got our switch and then our E-stop up here. And essentially what happens is this thing right here, this leg, when this leg is at the input voltage, it is turned off. And then when you ground this leg, then it'll let power pass through it. And over here we've got some pull-up resistors. So what happens is this leg is weakly pulled up to the input voltage, which comes down through here. And then the E-stop is a hard pull-up to input voltage. So no matter what happens, the E-stop should hard pull it up to input voltage and then turn it off. And then the power switch right here is just grounded on one side, and then the top side has a stronger pull down than the weak pull down that is there when nothing is there. So essentially you let it float, it's going to be off. You pull it down to ground, it's going to turn on the entire board. But if you hit the E-stop, it's gonna pull it hard up to input voltage and turn it off. Hopefully you can see, I mean, that thing looks good, but I mean, I've checked the diode on that MOSFET and it is not good. So, and here's the back side, nice and simple. So it kind of sucks that it died, but if I really wanted, I could use this board for something else, another project. I mean, maybe I could build this as like a laser engraver or something, and maybe I could try to replace that MOSFET. But for now, whatever, we have the new one and it should work out great and be safer. So there we go. Now that we have fixed the issues on our CNC here, we have gotten some goodies. So I've actually already unboxed a lot of the goodies, but what we didn't show is this, which should be pretty good. So this is gonna be, yeah, it's called a dust shoe. And it is pretty simple. Just some brushes that help, that you can put a shop vac onto and suck up all the chips. It does come with like a little short brush one and a long one, but I think it should be pretty good. So let's put this on real quick. This is nothing fancy at all, but I do like this. They use magnets. Yeah, and they even make it so you can't do that. So it should be, you know, this is you can't mess this up. But if you want, you can just pull that off and then have it with basically no obstruction out of the normal. So I think I'm going to clock it right there so we have a decent amount of space, and then the shop vac will come off like that. And it should just be as simple as going like this and getting these nice and, well, not super tight, but decent bit tight. I will say it does limit how far up you can put the spindle. So here's the short shoe, and if I had to venture, I'll probably use the short shoe most of the time. But we do have the long shoe. So I guess, yeah, this is mainly for pulling on and off bits, and then you can put your shoe on and not get chips all over the heckin' place. I think with that, we are just about ready to start trying to cut some stuff. So let me just, over the last little bit in buying bits, I will say when I got them in hand, these ones from Amina Tool, they were, you know, leaps and bounds more expensive than the Genmitsu stuff. But holy moly, the craftsmanship on this is just amazing. And I do want to support, you know, USA companies. So both of these bits just, it's hard not to kind of gush over how good they are. I haven't used them yet, so maybe they perform like crap, but I doubt it. Hopefully in this video, we'll get to use it. And I have, so as you may have noticed, I have used this for a few different things. I did my first engraving, kind of in a time crunch to get my sister engraved something for her. And it went okay. I just used one of these bits that came with it. And it was into some polymer. And at least I'm pretty sure it's polymer. And the problem is that like the chips, it was really hard to clean. So, but I want to start with wood. So now that we have this on here, yeah, let's find something wood and we'll get this completely set up different and find something to carve. That sounds like fun. Okay, so I've got everything set up. For my end goal, we need to set up a spoil board. So this is like a little mini spoil board that we're going to cut out and make it level. And then it'll also work as a tool holding piece. So let's cut this out and then I'll talk about what I want to do. I'll just preface this that this is the first time I've ever cut wood with this. I am totally guessing at the speeds and feeds, and so we will totally see how this goes and see how the extractor goes. It's gonna be a little loud, so make sure you got your hearing protection on. And I guess we'll see how this goes. Wish me luck. Before we get on to the next step, there is 2 small upgrades that we need to do now that I have some time to think about it. So we've been using this shop vac, which I got used, and it is heckin' loud, and the tube is honestly a little big. So recently this just came in. I'm trying this out. It was actually decently cheap, and this is what, VacMaster. The actual model number is the VWM 510, and I've heard this one is really quiet, and it's smaller, so I'm hoping that this guy will be nice and quiet, and I can get it dedicated to the CNC, so it's just kind of be tucked away. And the one thing that might be kind of nice, I don't know if I'll use it, it's got like a remote start function, so I could just always have it plugged in and tucked away, and then start it up with the remote. And we'll see how that works. We need to get it unpackaged and then connect it over here, and we'll just try it out. And then the other thing we need to do is, I didn't like the clamping setup that they have with these. It's okay, but we need to revamp it. I bought a bunch of bolts, and I bought a little organizer, so we need to organize those, then I'll talk about them. So let's get the vacuum undone, and then we'll deal with that. Okay, so just a comparison. And then that's pretty good. All right. So this is my new clamping setup. So let me just run it through real quick. As you can see, I basically just have the washers and the clamps here. And then I went to the hardware store and rated all the sizes that I could for an M6 with a 1.0 thread. And then this cubby this cubby was cheap and had the perfect number of bins in there. So I just labeled them. So yeah, we basically start from a 16, I think it's 16 millimeter length, all the way up to a 50. And the reason I did this, the original clamping, they had these guys to push against the bed, and then they had the other ones to clamp down from the top. So what I decided to do here is, again, it's an M6 by 1.0 thread, and because I have all the different sizes with the washers, for the screw that I got Allen on top and a low profile, and so it's nice and flat on top, which means these can either be used to clamp down or push against the bed. And because I have all the different sizes, what it means is that I just use one size to clamp down or to push against the bed, and then the next size up to clamp it down onto the bed. And so with all these different sizes, then now I can have a really low profile clamping setup. So if I have something small, I can use the small ones. If I have something tall, I can use the tall ones. Because as you might have noticed in that last cut that we just made for the jig to hold it down, this clamping setup got in the way of my chip extractor, of the vacuum thing, whatever you call it. It was hitting it because the bolts were too high. So with this low profile setup, I should be able to find the perfect height and have it be nice and low profile, so that way the bit can clear it and I don't have to worry about my cam like running the bit into any of my clamping setup. So here's another little upgrade, and we can add more to this later if we need, but this should be, I just got 4 of each, so should be good. With those mods done, we are ready to continue our adventure on using our CNC to modify our CNC. Let me get you a good shot. It's actually up here on the Z-axis that we're going to modify. So let me turn this and get you really zoomed in here to show you. Here is the Z-axis, and we have an upper limit switch and a lower limit switch. And one thing I have realized is that right here, the second the limit switch gets hit, you gotta like reset the board. But as this comes up, you can hear the click right there. So there's the click, but I've noticed that I actually have a decent bit of space on my Z-axis that I can still use, and even more so here on the bottom. So in the current situation, these limit switches are doing their job, but they're also limiting the amount of Z-axis that I have. And I do have to say, the biggest limitation, or the limitation I've ran into the most on this machine, has been the amount of Z-axis, the amount of height that I have to work with. Because often the parts I want are like too tall, or it's hard to get it down low enough. And so if I can maximize the Z-axis on this machine, then that's great. So what I'm gonna do is we're going to modify this polymer piece right here, this plastic piece. And essentially what we're going to do is just use the CNC and use this holder to shave off the correct amount on the top and on the bottom. So that way these limit switches will only get activated just before we actually hit our real limit. So then we can get the most out of our Z-axis on this. So what we need to do, there's a little bit of play here in them, so we're going to take this off, find the height between this plate and there, and then the bottom plate and here when we, like our limits, and then put these on and find where they stop, and then we'll cut off the rest from that. So let's get to doing that. I just realized rather than having me struggle with all of the measurements on all of this, we could just use the CNC to do all these measurements. So yeah, I think the CNC will be able to do it more accurate than me. So let me get this fired up so we can control it, and then we'll just use the control of the Z-axis to figure out our measurements there. Now that we have the machine powered on and we can actually move it, see, move it up and down. What we're going to do is take off the Z-axis. I'm going to manually move it and then reset the Z-axis. And then up here we can read at where it thinks it is. Move it down, put this on, move it up until it hits the stop. Boom. That should give us the readout for it. And that should be a bit easier than using calipers. So, and the other thing too is it's hard because I can push it past when the switch hits it. You know, when the switch clicks. And so I'm just sitting there trying to slowly sneak up on when the switch clicks and then be like, okay, that's where it would hit it. But if I use the machine to manually stop when it would stop when it hits it, then I don't have to worry about that. So now that we have it like this, we can literally move this all the way up. Boom. Okay, so now we zero the Z-axis, and then we can move that down. Put our limit switch back on. Now that we have it in there, we can move it up. I'm just going to slowly bring this in. So 4.531 is how much we need to cut off the top. So we have over 4 millimeters. I believe it's in millimeters here on the top. And we can actually basically measure that right there just to verify I know my measurements. So this is actually probably a better way than what I was doing before, because this is 5.6 on there. And granted, we're not going to get those squished perfectly, but yeah, 4.531. All right, let's do the bottom. I got the Z-axis block in here, and as you can see, I kind of just used 2 of those plates to put them in. So like this plate, because I didn't have a screw here, I just used this plate and then that plate on top to then be able to clamp this down. And it does really well. I also replaced these clamps so they're low profile. And then I finally figured out my paths, my tool paths for these. And I got the clearance height when coming off the part. I set at like 14, which is 1 millimeter above this height here. I could have done 3 millimeters, you know, or really close, and it might speed it up. But Again, I'm just more worried about not damaging them. If I had practice pieces and I could easily remake this, then I wouldn't be so worried. But no, so this is like kind of one shot. Either we screw it up or we don't. So I set the origin. I set the origin for doing this operation here on this top hole. And then the height is going to be the top of this surface. Granted, I did put some tape on here to, like, I don't know, keep it from fraying as much on the edges. And I was going to try to set my origin in the machine, but I figured this might actually be a better option. So I got the 1/4 inch collet, and I have this little deburring tool. So I think I'm going to come in with the deburring tool, find my X and Y, and then for the Z, I'll set it when I put back in this 1/8 inch bit. And then I might run it a couple times up above just to make sure, you know, everything's looking good. And then it'll be go time and we'll actually run it in there. I will say I wish the brushes didn't hide the bit so much, because that would give you guys a better shot of what's going on. But also, I don't want my bench to be a huge mess. So I'm still going to put on the little extractor, or, you know, to get all the chips out. But we should be good to go. So probably just time-lapse most of this, and you guys can watch me set it up and try to cut this out and see how it goes. I mean, cross our fingers we don't screw it up. Okay, so I had to fix a couple things in the code that was generated. Basically, I wanted it when it gets done, I want it to just go up to the safe zone rather than go all the way home or something like that, because that was a little scary, just having it jolt over there. And then also when it starts, getting into the position in the beginning, it does X, Y first and then changes the Z, I think. So it's really scary, because if you have the Z down too low, then it's going to crash into your part before it even starts. So that's why I'm over here, close to where it starts. I'm going to go down closer to where it is, and then hopefully I have my speeds and feeds correct. But we're just going to send it. We're just going to go for it. So here's that. Let's see. Turn on our vacuum, and we're going to just go for it. Well, looking at our part, it looks like definitely shaved off quite a bit from the top. But we didn't shave off hardly anything on the bottom. I'm going to check my measurements and see how bad we just screwed that up. And go from there. Well, I think that went pretty good. I was a little worried because it didn't shave off as much as I thought it would on the bottom. But I also knew that it was going to shave off more on the top. And after measuring it a bunch of times, I think we're good. And we didn't damage anything. It was the perfect depth where it just started to cut into the wood a little bit. So I'm feeling good enough, and we can even bend the little arms to like do finer adjustments. So let's pull these off, pull it out, and put it back on and see how we did. Okay, so yeah, I must have had my offset or like my zero was probably not set that correctly because we did not shave off enough on the bottom. We shaved off a bit too much on the top, but it was pretty close. I mean, it was maybe like half a millimeter off, and that's probably just my fault, my measurements. Again, I'm new to this, but we were able to get the adjustments out of just bending the little tabs, and so that's a lot closer. And like, you know, we're going to use the full range now. Well, that is where this video is going to end today. I really wanted to end the video by cutting out and engraving aluminum. Unfortunately, the aluminum stock, or like the scrap that I had, I thought I could use. Turns out it's actually, this alloy of aluminum is really hard and probably too hard to machine out on this guy. It doesn't have very good machinability properties. So, and this video has been going on for a few weeks, and I've been trying to get this done so we can move on because there's some other way more pressing projects, but I just don't have the aluminum for it right now. And after looking at all the footage, this video is going on a little too long. So we're gonna cut it off here. I think we've done some great upgrades on the CNC. It's working a lot better now. So we have like the full height and everything, and we have it just way better set up. So I'm really happy with the progress we've made in this video. In the next part, because there will be a next part, we're gonna actually, I'll order some aluminum, we'll get the right aluminum, and then we'll actually start cutting out aluminum on it. But so glad you guys could come on this adventure with us on this project. I hope you guys hit the subscribe button so I can see you on the next project. But until then, I hope you guys have a great day. Oh, also, for the vacuum and some of the other stuff, I do always put links down in the descriptions. If you didn't know, in the description you can typically find most of the parts and other stuff that I'm using, just so that you guys don't have to go up and search it for it. So check the description, but we will see you guys next time. Bye!